So, welcome back to my channel. Hope you're all doing well. So, today we are going to discuss problems on the topic linear differential equations of higher order with constant coefficients. Okay. So, let us solve the problem. Solve d square minus 3d plus 2 into y is equals to cosine hx. So, here the right hand side function is cosine hyperbolic function. So, cosine hx, so it can be converted into an exponential function. So first to solve this, since this is a non-homogeneous function, so we have the complementary function and the particular integral as the solution. So here we have to find the complementary function as well as the particular integral. So if the given equation is homogeneous, then we will find only the complementary function. Since here we have the right hand side function as a hyperbolic function or cosine hx, so we need to find out the particular integral also to find the total solution. Okay, so now to find the solution, we will write down the auxiliary equation. So the auxiliary equation, so auxiliary equation is given by m square minus 3m plus 2 is equals to 0. So now factorizing, so it becomes m square minus 2m minus m plus 2 is equals to 0. So factor by grouping, so group this two. So m into m minus 2. So here we take minus common. So minus of m minus 2 is equals to 0. So again we have m minus 2 as the common factor. So m minus 2 into m minus 1 equals to 0. So each factor is equals to 0. So m minus 1 is equals to 0. M is equals to 1. M minus 2 is equals to 0. M is equals to 0. So from the auxiliary equation, we got the two roots. So here, what is the nature of the roots? The nature of the roots is roots are real and different. So what is the complementary function? So therefore CF is equals to YC is equals to C1 into e power m1x plus C2 into e power m2x. So that is the formula for writing the complementary function for the roots which are real and different. Okay. So therefore yc is equals to e1 into e power. So m1 is first root. So that is 1 into x is x plus c2 into e power m2 is 2. So therefore it is 2x. Right. So this is equation number 1. So we got the complementary function. So now since we have the right hand side function, so we need to find out the particular integral. So we will do that one. Okay. So now, so the given equation, so what is the given equation? D square minus dd plus 2 into y is equals to cosine hx. So now this can be written as e power x plus e power minus x upon 2. So instead of cosine hx, we will take this one. Okay. So cosine hx we have already learned in our lower classes. So cosine hx can be written as e power x plus e power minus x by 2. So instead of this one, we will be using this one to find the particular integral. Okay. So what is the procedure for finding particular integral? So this is nothing but f of d into y is equals to e power x plus e power minus x by. right? So therefore now for finding pi, so for finding pi, so that is equals to yp equals to 1 by f of d into e power x plus e power minus x by, so that is the procedure to find out the pi. So yp is equals to 1 by f of d into e power x plus e power minus x by 2. So therefore yp is equals to, so what is f of d? 1 by d square minus 3d plus 2 into, so now we will split this, we can write it as e power x by 2 plus e power minus x by 2, right? So therefore yp is equals to, so we'll move this inside, so we'll get two terms. So we can take this 1 by 2 as a constant, so 1 by 2, 1 by d square minus 3d plus 2 into e power x. So move this again, so 1 by 2 is a constant, again we will plus 1 by 2 into 1 by d square minus 3d plus 2 into e power minus x. So here we have to find out pi1 and pi2. So since there are two terms, so we'll find out these two values. Okay. So yp, therefore yp is equals to. So now here this is an exponential function. This is of the type e power ax when the function, when the right hand side function is of exponential function or e power ax. So what is the procedure for that? Uh, so look here, okay. So 1 by f of d, 1 by f of d into e power x. Now this is exponential function. So what we have to do, what is the procedure for this one? So instead of d, we have to put d is equals to a in the denominator, provided the denominator should not become equals to 0. So put d is equals to a. Put d is equals to, what is a? A is the coefficient of e, x in e power ax, right? So provided the denominator is not equals to 0. So instead of d, we will put d is equals to a. So that is 1 by f of a into e power ax. So that is a rule. That is the first case. Provided f of a is not equals to 0. Similarly, what happens now? There is another case when the denominator becomes 0. So when we are putting d is equals to a in the denominator, so in that case, what we have, when the denominator is becoming 0, when we are putting d is equals to a in the denominator. So what we have to do is we have to put, that is the second case, okay. So that is the second case. What we have to do, put d is equals to d plus a in the denominator. So we will put d is equals to d plus a in the denominator and move this e power x to the left of the operator. So what we do is we will write it as e power ax into 1 upon f of d plus a. So that is the thing what we have to do in two different cases. right? So again listen. So when the function is exponential function, that is e power ax. So to find the particular integral, what is the procedure? We will write down as usual 1 by f of t into the function. So here it is exponential function e power ax. So what is the procedure? We will put d is equals to a in the denominator, provided the denominator is not equals to 0. Second case, when we are putting d is equals to a in the denominator, if it is becoming equals to 0, in that case what we have to do? We have to put d is equals to d plus a and move this e power x to the left of the operator. So we will write it as e power x into 1 by f of d plus a. So those are the two things what we have to remember while solving the problem. Okay. So now in this case, so e power ax, so a is 1 here. So here we can write down this denominator in terms of factors so that it is easy to understand whether the denominator is becoming equals to 0 or not. So we can write it as, so d square minus 2 can be written as d minus 1 into d minus 2, right? E power x plus 1 by 2 into 1 upon d minus 1 into d minus 2 into e power minus x. So now in this case, what is a here? The coefficient of x in e power x. So a is 1. So if I put d is equals to 1 here, the denominator becomes 0. Here if I put this factor is not becoming equals to 0, but if I put it here, this factor is becoming equals to 0. So in that case, what we have to put? You have to put d is equals to a in those factors which are not vanishing or for which the denominator is not becoming equals to 0. So therefore, so I will put d is equals to 1 here, and I will not put d is equals to 1 here. So because this factor is becoming equals to 0. So therefore here what we do is, so yp is equals to, so here 1 by 2. So I am putting d is equals to 1 here. So what it becomes, so this remains as it is, d minus 1 into 1 minus 2 into e power x. Similarly here also what we do, 1 by 2. So here a is e power ax, so a is the coefficient of x, so that is minus 1. So if I put minus 1 here, so this factor is not becoming equals to 0, this factor is also not becoming equals to 0. So we can put it directly there. So therefore 1 upon minus 1 minus 1. So here minus 1 minus 2 into e power minus x, right? So we have the problem only here, okay? So here if I am putting d is equals to 1, so this factor is becoming equal to 0. So we will not put it there. So we will leave it like that. So therefore this is changed as, so yp is equals to, so 1 minus 2 is minus 1. So it is minus 1 by 2. 1 upon d minus 1 into e power x. So now this we have got it already. So minus 1 is minus 2. So 1 upon 2 into 1 upon, this is minus 1 minus 1. So minus 2 times minus 1 minus 2 is minus into e power, right? So therefore yp is equals to, here what happens now? Now as usual, so here f of d e power ax. So the coefficient of x is 1. So if I am putting d is equals to a, that is d is equals to 1, this is vanishing, the denominator is becoming equals to 0. What we have to do? So in that case, we have to put d is equals to d plus a. So minus 1 by 2 and move this exponential function to the left of the operator. So e power x into 1 by, so d plus a, and we have to put a is 1. So d plus 1 minus 1. So here minus 2 into 2, 4, 4 into 3 is 12. So minus into minus plus 1 by 12 into e power x. Right? So therefore yp is equals to, so minus 1 by 2 e power x. So now d plus 1 minus 1 gets cancelled. So it is 1 upon d plus 1 upon 12 into e power. So this can be written as, therefore this is equals to minus 1 by 2 e power x. So 1 upon d. So 1 upon d is what, it is the integration. So it becomes x by 1 factorial plus e power minus x upon. So that is the particular integral of this problem. So therefore, this is equation number 2. This is 2. Now we have found the complementary function, that is yc, and we have found the particular integral. So what is the total solution? So therefore, the total solution is, therefore, solution is y is equals to yc plus yp. So we have to add equation 1 and equation 2. So to get the total solution, right? So therefore, we can write it as y is equals to, yc is how much? c1 into e power x plus c2 into e power 2x plus, so plus here we have minus, so we will put minus 1 by 2 e power x into x. So x by 1 factorial is 1 plus e power minus x. So this is a procedure to find the solution for the problem which is of the type linear differential equations of higher order with constant coefficients. Okay, so that is a procedure you have to follow to solve this problem. So okay, well, we will do another problem where the function is of another type. Here the function, right hand side function, is an exponential function. Cosine of x, it is a hyperbolic, so it can be written as e power x plus e power minus x by 2. So this is exponential function. When the right hand side function is exponential function, what we have to do? We have to put d is equals to d plus a in the denominator, provided the denominator is not becoming equals to 0. If the denominator is becoming equals to 0, what we have to do? We have to put d is equals to d plus a. So that we have to remember. Okay, right. So we'll go for another problem now. So now solve d square plus 3d plus 2 solve question number 2. Okay, solve b square plus 3d plus 2 into y is equals to d square plus 3d plus 2 into y is equals to sine 3x is equals to sine 3x. Now you see what is the difference between the previous problem and this problem. In the previous problem, we have the right hand side function as a hyperbolic function or exponential function. Okay. So here we have trigonometric function. So for when the right hand side function is trigonometric function, we follow another procedure. So that we will do it. Okay. So first we will write down the auxiliary equation. So what is the auxiliary equation? So the auxiliary equation is m square plus 3m plus 2 is equals to 0. So therefore m square plus 2m plus m plus 2 is equals to 0. So grouping m into m plus 2 plus 1 into m plus 2 equals to 0. So m plus 1 into m plus 2 equals to 0. So therefore m plus 1 equals to 0. M is equals to minus 1. M plus 2 is equals to 0. M is equals to minus 2. So what is the nature of the root? What is the nature of the root? So nature of the roots are real and different. So therefore complementary function CF is equals to YC is equals to C1 into e power m1x plus C2 into e power m2x. So this is m1, this is m2. So therefore YC is equals to C1 into e power minus x plus C2 into e power minus 2x. So this is number 1. So we got the complementary function. So then we have to find out the particular integral, is pi. So for pi, what we have to do? So pi is equals to 1 by t square plus 3d plus 2 into sine px. So that is the thing what we have to do to find out the pi. So now since the function is a trigonometric function, what is the procedure here is we put we will put two cases are there. We will put what we will put only one case, sorry. So we will put d square is equals to minus a square. What is this d square? Here we have d square. What is a square? A square is this is sine ax, sine ax. So a is 3. Okay, so a is 3. Okay, so here a is the coefficient of x in sine function. So when the denominator, provided the denominator is not equals to 0. When the denominator becomes equals to 0, so we have to use the formula. So therefore we will use here put d square is equals to minus a is 3, that is 3 square. So we will put d square is equals to minus 9 in the wherever you are finding d square. So we put d square is equals equals to minus 9, provided the denominator is not equals to 0. So when the denominator, if we are putting d square is equals to minus a square and the denominator is becoming equals to 0, then we have to use the formula, right? So therefore, pi is equals to, so d square is equals to, so 1 upon, so d square is minus 9, so minus 9 plus 3d plus 2 minus plus 3d plus 2 into sine dx, right? So 1 upon minus 9 plus 3d plus 2. So simplifying, so what happens? So this can be written as, so simplified, what happens? Minus 9 plus 2, it becomes minus 7. So take this 3d minus 7, right? Into sine. So now it is simplified as 1 upon 3d minus 7 times sine 3x. So here we don't have d square, to put d square is equals to minus a square. So what, in that case, what we have to do? So what we will do here, we don't have d square. So because the procedure is we have to put always d square is equals to minus a square in the denominator, provided the denominator is not equals to 0. If it is equals to 0, we have another case. Okay. So since we don't have d square here, so what we do? So pi is equals to, I will multiply with 3d plus 7 into sine 3x by 3d plus 7 into into 3d. So what we have done here? So since here in the denominator we don't have d square, to put d square is equals to minus a square. So just we are multiplying with 3d plus 7 and dividing by 3d plus 7, so that this does not alter. Okay. So now this is therefore this can be written as, so this is a plus b into a minus b, a square minus b square 3d plus 7 into sine dx upon a square minus b square. So 3d square minus 7 square. So it becomes 9d square minus, right? So here we got now d square. So again we'll put d square is equals to minus a square. So d square, what is a here? A is a coefficient of x in sine. So this is equals to minus 3 square is minus. So therefore dd plus 7 into sine dx 1. So d square is equals to minus 9. So 9 into minus 9 into minus 9 minus, right? So this is equals to dd plus 7 into sine dx 1 minus 81, 81 minus, minus 81 minus, so that is equals to, the minus 1 upon, so it is 130, 80 plus 40 is 120, 9 plus 1 is 10, 130, 130 into dd 7 into sine, right? So again simplifying, so therefore, so this is yp or pi is equals to minus 1 by 130. Now take this, multiply this, so this is 3d sine px plus 7 sine px. So this is equals to minus 1 upon 130. So into d of sine x. This is d is nothing but derivative of sine 3x. So 3 into derivative of sine 3x is what? Sine 3x into derivative of 3x is 3. So 3 into 3 sine x plus 7 sine px, right? So that is equals to 3 into 3 is 9. So minus 1 upon 130 into 9 cos px plus 7 sine. So this is number 2. So now to find the total solution, we have to add the complementary function and particular integral. So therefore, the solution is given by y is equals to yc plus, right? Okay, is it clear? So we have to add equation 1 and equation 2 to get the total solution of this given problem, right? So next we will be doing another problem. So where the right hand side function is the algebraic function. So we have done here two types of problems. So the first on the right hand side function was the exponential function, that is e power ax. Now here in this problem we have done the right hand side function is trigonometric function sine 3x. So on the last problem we will be doing it on algebraic function. The right hand side is algebraic function, right? So you have to remember the procedures for different types of function. So when the function is exponential function, so that is e power x, what we have to do? We have to put d is equals to a in the denominator, provided denominator is not equals to 0. Similarly, when the function is becoming equals to 0, when we are putting d is equals to a, so that is a different case. Okay, but for sine ax function or cosine ax function, what we have to put in the denominator? We have to put d square is equals to minus a square. So now when the right hand side function is the algebraic function, we will see what we have to do. Okay, solve d square plus 4. So this is the third problem. Solve a d square plus 4 into y is equals to x cube equals to x cube. So now here you see this is algebraic function. Okay, so x cube is an algebraic function. So same as it is, we will write on the auxiliary equation. So what is auxiliary equation? Auxiliary equation is given by m square plus 4 is equals to 0, m square is equals to minus 4. M is equals to plus or minus square root of minus 4. So that is equals to plus or minus square root of minus 1 is I. So square root of 4 is 2 plus or minus 2I. So that can be written as 0 plus or minus I2 or 2I. Both are same here. So here real part is 0 and imaginary part is 2. So in the previous two problems, we got the roots as real and different. Here we have the imaginary roots. So for the imaginary roots, how to write down the complementary function. So that is a different formula what we have to do. So therefore, yc is equals to cf is equals to, so e power real part into x, e power real part into x. So you have to remember the cases when the roots are real or imaginary, what we have to do. When the roots are real and different, when the roots are equal, and when the roots are imaginary. So what is the formula? E power a real part into x, e power real part into x into c1 cos imaginary part into x plus c2 sine imaginary part into. So that is the formula for writing the complementary function when the roots are imaginary. E power real part into x into c1 cos imaginary part into x plus c2 sine imaginary part into x. So here what is the real part? This is the real part. So this is the real part. Real part is 0. Imaginary part. This is imaginary part. Imaginary part is 2. So therefore, yc is equals to F is equals to e power real part is 0. So e power 0 into x is 1. So we need not write. So e power 0 x c1 cos. What is the imaginary part? Imaginary part is 2x plus c2 sine imaginary part is 2. So therefore yc is equals to, so this is 1. So therefore c1 cos 2x plus c2 sine x. This is yc. Now we will find out the pi. So for finding pi, what is the procedure? Pi is equals to 1 upon e square plus 4 into x cube. So now here we have the algebraic function. So for the algebraic function, so we always try to write down the denominator in terms of 1 plus or minus b. So when the function is an algebraic function, if you want to find out the particular integral, what we have to think is write down the denominator in terms of 1 plus or minus b. So in this type, we have to write down the denominator 1 plus or minus b, right? So 1 we have to get. So here 4 is a constant, so we will take it outside. Therefore 1 by. So if I take it 4 outside, 1 plus d square by 4, right? So 1, so if I take 4 common, so now if we multiply 4 into 1 is 4, 4 into d square by 4 is d square. So both are same. Okay. So when the function is an algebraic function, what we have to do, we always try to write down f of d or the denominator in terms of 1 plus or minus d. So that is what you have to remember. So then after writing that, I will take this to the numerator. So therefore, pi is equals to 1 by 4, 1 plus d square by 4. So I will take this to the numerator, the power becomes minus 1 into x cube. So this is what we have to do when the function is algebraic function to find the particular integral. So always try to write on the denominator in terms of 1 plus or minus d. Then we will take it to the numerator. So now here we will be using the formula. This is of the type 1 plus d to the power minus 1. So 1 plus d. So 1 plus d. 1 plus d to the power minus 1. So what is the formula? Binomial expansion. 1 minus d. So we will be getting here alternatively positive and negative. 1 minus d plus d square minus d cube plus so on. Right? So we will be using the expansion here. 1 plus d. Instead of d, we have d square by 4. 1 plus d to the power minus 1. So how many terms we have to use? We have to use only the terms in the expansion, up to the terms in the expansion where the derivative of the function will vanish. So for example, here we have x cube. What is the derivative of x cube? The first derivative of x cube is 3x square. The first derivative of x cube is 3x square. Similarly, what is the second derivative? Second derivative is derivative of x square is 2x. 2x into 3 is 6x. Right? Similarly, the third derivative is how much? 6. Fourth derivative is becoming equals to 0. Right? So fourth derivative is vanishing here. But here we have d square. So now we will write down it as 1 upon 4. So 1, what is the formula? 1 minus d. 1 minus d square by 4 plus d square. So squaring. So it becomes d power 4 by. So we can stop here. So here fourth derivative. The fourth derivative is already 0. So we can stop here. We need not write all the terms here. Right? Into x cube. Right? So this is equals to 1 upon 4. 1 into x cube minus d square by 4 into x cube plus d power 4 by 16 into x cube. So this is can be written as x cube. What is the second derivative of x cube? Derivative of x cube, first derivative is 3x square, second derivative is 6x. So we have d square, second derivative of x cube is 6x. So minus 6x upon. So fourth derivative of x cube. Fourth derivative is becoming equals to 0. So we will write down this is equals to take it inside. So x cube by 4 minus 6x by 4 into 4 is 16. Can cancel this one, simplify. So this is equals to x cube upon 4. Can cancel h2 minus px by. So this is pi or yp. This is number. So therefore, the general solution is given by y is equals to yc plus yp. So therefore, y is equals to. So we will add a 1 and 2 to get the total solution. So therefore, y is equals to c1 cos 2x plus c2 sin 2x plus x cube by 4 minus px by 8. So that is the total solution, right? So here we have done the problems, three different problems where the right hand side is of three different types. The first one was the exponential function e power ax. So in that case, what we have to do, we have to put d is equals to a in the denominator, provided the denominator is not equals to 0. So if the denominator is becoming equals to 0, we have to move, we have to put d is equals to b plus a in the denominator and move e power ax to the left of the operator. In the second case, the right hand side function was the trigonometric function. So in that case, what we have to do, whether it may be sine ax or cosine ax function. So what we have to do is we have to put d square is equals to minus a square in the denominator, provided the denominator is not equals to 0. So if the denominator is becoming equals to 0, we have to use the formula. And the third case is this one. So here we have a algebraic function. So to find the pi, and the function is algebraic function, you always try to write down the denominator in terms of 1 plus or minus d, and we will take it to the numerator and expand it binomially. So how many terms we have to take, it depends on the given function. We have to take only those terms up to which the denominator, up to which the differentiation is becoming equals to 0, right? Here the fourth derivative is becoming equal to 0, so we will take only up to, we can take only up to here. This one is not needed because this is 0. Okay. So therefore, three different cases, problems we have done. Okay, so if you like my video, kindly subscribe to my channel and hit the like button, and kindly as well as share with your friends. Thank you so much for watching.